Welcome back everybody to the second part of my particle effect tutorial series. In this part I'm going to show you how to create a particle effect that travels from one point to another point. In future videos I'm going to show you how to create more complex forms of this particle effect, like this one in the middle that moves between an unlimited number of points, and then this one on the left which actually curves between all of the points and just makes it look a little bit smoother, a little bit nicer. But these two are for future videos. In this one, I'm just going to be showing you how to create a particle effect that moves from one point to another point. And along with that, I'm also going to show you how to create some interesting variations of this particle effect. Like we have the basic particle effect, one where you have these additional particles that makes it look a little bit nicer, a little bit more complex. One that moves a little bit faster. One where you actually have two instances of the particle effect traveling along the line, and then one that bounces between both of the points instead of just moving in one single direction. And now that you've seen what the final product is going to look like, before we hop into IntelliJ, I just want to show you a quick diagram that will hopefully give you a better idea about the math behind this particle effect. So before we hop into the code, I just want to show you this diagram that I created that shows you the math behind the particle effect. So here we have this black line, which is the line the particle is going to be moving along. And then we have location 1, which is going to be the initial location the particle starts at. And we have location 2, which is going to be the destination location that the particle is going to end up at. And then we also have all these blue dots, which are going to be all the individual particles that we spawn along the line to create our particle effect, along with their indexes, which is the order that the particles are going to be spawning. And then if you look in the top right here, you can see a crude animation or visual of what the final particle is going to look like. Our actual particle is going to look a lot nicer, but it's just an example. So the math with this might seem complex at first, but it's actually fairly simple. So I'm just going to show you how to find the X position, and then you can apply it to the Y and Z position. But basically, the first thing we want to do is get the distance between location 1's X position to location 2's X position. And so that'll just be this line right here. And the way we get that is we just take location 2 or the destination's X position and subtract location 1 or the initial X position, and that gets us that line right there. And then what we want to do with that is we want to use it to get the distance between any two particular particles that are going to be spawning along our line. And the way we do that is we just go ahead and take that full distance that we computed and divide it by the number of particles that we are going to be spawning along our line, which in this case is 9 particles, so we'll just divide that by 9, and that gets us that distance right there. And then we can go ahead and take this distance and use it to find the X position of any of the particles we want to spawn. So for example, this particle at index 0 is going to be this red dot here. All we have to do is take location 1's X position, add the distance between any two particles we computed, and multiply it by the index of the particle, which starts at index 0, and then ends at index n minus 1, where n is the total number of particles that we're going to be spawning. I'm not going to go into too much crazy detail about it, but hopefully this diagram and the equation I have on here gives you a better idea about the actual math that is going on behind the scenes here. But with that being said, let's go ahead and hop into IntelliJ and actually start writing some code. So first up, we're going to create the basic line particle effect. And I already set up this project that allows me to type in a command with a particle effect name, and it will play that particle effect for me. If you want to check out this project, I'll upload it to GitHub and include it in the description below. But pretty much all the code I write in this run effect method right here, you can go ahead and just copy and paste it anywhere in your project you want to use it. But let's go ahead and just hop into our code. Okay, so the first thing we want to do is I'm just going to go ahead and create a new variable. I'm going to create an int, and I'm going to call it speed, and I'll set that equal to 1. And then this will make more sense in a moment, but I just want to create a speed variable to be able to control the speed of our particle effect. And now that we have that, I want to just go ahead and create a bucket runnable. So all I have to do for that is just type in new bucket runnable. Then go ahead and have my opening and closing curly brackets, Gonna hover over here, implement method, okay, and then just have it create this run method for me automatically. And then with that, after this final closing curly bracket, we're just gonna do .run task timer. This is gonna take in a few arguments. The first one is just going to be the Java plugin instance. The next one is going to be the delay, which is the number of ticks in between the bucket runnable being created here to the first time this run method is actually called, but we want our particle effect to start playing immediately, so I'll just set that to be 0. And then finally is going to be the number of ticks in between every time this run method will be called. So, for example, there's 20 ticks per second, so if we set it to be 1, this run method will be called 20 times per second. If we set it to 2, this run method will be called 10 times per second. If we set it to 20, it'll be called once per second, so on and so forth. And then this is where our speed variable comes into play, so I'm just going to go ahead and insert that there. And now we have the basic setup for our particle effect setup. And now real quick, one additional thing I just want to do with this bucket runnable is I just want to take a integer I created above called task ID, and I'm just going to go ahead and set this bucket runnable equal to that, and then just after that run task timer, I'm just going to add .get task ID. This just lets me keep track of the task ID, so it's easier for me to stop the particle effect whenever it runs. If there's ever a point I actually want to stop it, it makes it easier and neater to stop it. It's good to practice to keep track of the task ID of all your bucket runnables. But now that we have that, the first thing we want to do to actually create our particle effect is we want to figure out how many particles we're going to be spawning along our line. So there's 2 different ways we can do this. The first one, option one, is just going to be giving it a number and telling it this is how many particles we're going to be spawning along that line. And this way works perfectly fine. It's a little simpler, but it works just fine. The only downside to it is if you have a longer line or shorter line, maybe you don't know what the length of the line that the particle is going to be moving along is going to be. It could make it look a little cramped or a little stretched, but in a lot of situations it'll work, and to do that all we have to do is just go ahead and do int, create a new integer, and I'll call it particle count. And then we're just going to set that to whatever number of particles we want to make up our line, so maybe 50, for example, if you want 50 particles to make up that line. And this way works just fine in a lot of cases, but if you don't know the length of that line again, it could make it look stretched or squished together and a little awkward. So in a lot of cases, I think option 2 is going to be much better. So with option 2, basically we're just going to tell it the desired distance that we would like to have in between every particle along our line, and then we'll do a little equation to make that happen and figure out the number of particles that should make up our line in order to satisfy that desired distance. So the way we do this is pretty simple. All we have to do is create a new double, and we'll just call it dist between particles. And then I'll just set that to be 0.25, a quarter of a block between all of the particles. And then I'm going to go ahead and create int particle count. And then I'm going to set that equal to, well, I'm going to just comment out this particle count I created up here. And so now the way we compute this is we just are going to go ahead and get the distance between location 1 and location 2. Just for reference, location 1 is the initial location that the particle is going to be starting at, and location 2 is going to be the final location that the particle is going to end at. I already created these variables, but you can just replace them with whatever your location names are. So we just have to go ahead and do loc2.distance loc1, and that'll automatically get that distance for us. And now we want to take that distance and divide it by the desired distance between particles. So I'm just going to go ahead and divide that by dist between particles. And now that is the crude version of the number of particles to spawn along that line to fit that desired distance. But there's going to be a couple things that we're going to do real quick just to neaten that up a little bit. First off, we're just going to go ahead and surround that with parentheses. And then in front of that, I'm just going to go ahead and do math.round. And that'll just round it up or down to make it a little bit more accurate, a little bit neater. And then the second thing we're going to do is I'm just going to go ahead and surround that all with parentheses again. And then I'm going to do math.max. And then right after that math.round I'm going to do comma 1. And all this does is it ensures that there's going to be at least one particle spawning along that line, no matter how long that line is, even if it is shorter than that desired distance. And one last thing we have to do just to make Java happy is we want to cast this to an int. So just go ahead and do that right there. And then there we have our particle count. And now the next thing we want to do is we want to actually find that x, y, and z length between any two particles, just like I showed you in the diagram earlier. So the way we do that is pretty much the exact same thing. Basically, we'll just create a new double. I'll call it xdist for the first one. Then I'm just going to go ahead and set that equal to the final destination location, which is loc2 for me, .getX. And then we'll subtract loc1, which is the initial position, .getX. And then I'll take that whole thing and just divide it by our particle count. And nice and simple, that is our x distance between any two particles. Now we're just going to go ahead and do the exact same thing for our y and z positions. So we'll just do double y dist equals to loc2.getY, subtract loc1.getY, and then divide all of that by particle count. And then for the last one, I'm just going to copy, paste, replace that with z, get z, and perfect. That is all we need for that. Next up, we just want to go ahead and create a new integer right here, int. I'm going to call it idx for index, and we want that to initially be 0. Now with that, we can go ahead and move inside of our run method. Now there's a few things we have to do here. First off, we want to increment our index every time we spawn a particle. So all we have to do for that is we just have to create an if statement. And then within that if statement, we're just going to do idx plus idx. And while index, after we increment it, while it is greater than or equal to our particle count, that means that it is going to be starting to move past our line, which isn't good. So we just want to go ahead and do idx is equal to 0. That way, when it gets to the end of the line, we're just moving it back to the beginning of our line. Nice and simple. And then this plus idx will just increment our index every time we spawn another particle. Then now that we're incrementing our index, we can just go ahead and find the actual x, y, and z position that we want to spawn our particle at. And then that is very simple. All we have to do is just enter in, create a new double, call it x. And then we set that equal to loc1, or our initial position, .getX. And then I'm going to go ahead and add that x distance. And then I'm going to multiply that by the current index that we're at. And then nice and simple, that is our final x position that we're going to spawn our particle at. And then very similarly, we're going to do the same thing for our y and z positions. Just going to go ahead and copy and paste that in twice. Replace that x with y, replace that x with y, replace that x with y, and then our z, replace that x with z, x with z. Make sure we got all of our x versions replaced. We do, very good. And now that we have that, we can actually spawn in our particle nice and easy. The very last step, all we have to do for this is just get loc1, just any location in your world, .get world, get our world instance, and then just going to go ahead and do .spawn particle. This is going to take a handful of parameters. I already explained all the versions of this spawn particle method in my previous video, so go ahead and check it out if you need any refreshers or anything. But basically the first one is just going to be the particle we want to spawn. I'm just going to do particle.composter, the one I had in my example. Then we're going to give it that X, Y, and Z position. Then we're just going to say 1, we want to spawn 1 particle. And then just going to give it a few zeros, just because why the heck not? You don't really need these 3 leading zeros, I just include them for kind of wholeness sake for me. But now that we have this, we basically have our particle effect created. Let's go ahead and hop into Minecraft and check out what that looks like. So we are now here in Minecraft, and the way I set up this project is I can type in the command CPE and then give it the name of the particle that I created, and then it'll take my current location and set that to the initial location of our particle effect, or LOC1, and then if I run that command again, it'll take my location again and set that as LOC2, or the destination location. And so, for example, I can go ahead and go here, type /CPE, and then the name of the particle, which I just called it example. And then if I go over here and type in that same exact command again, you can see that the particle is now heading from the first location to the second location, going exactly where we want it to, exactly how we want it to. And it works in all directions, all vectors, all everything. So for example, if I just reset it, I can go back over here to the same starting position. Well, actually you can go a little over. Then I can go over just up here into the air. And then you can see our particle travels from our location 1 to our location 2. And of course, the way we have it set up, no matter how long or how short that line is, it will always be traveling at the same speed. And so you can see it's working exactly how we want it to. And now that we've finished the base for our particle effect, we can go ahead and work on some more interesting variations of it. So the next one I'm going to show you is actually going to be adding in some extra particles along with that green particle, and that'll just make it look a little bit more neater, a little bit more fancy. And so let's go ahead and just hop back into IntelliJ and start working on it. So to add that little bit of flair, it's actually very simple. Basically, all we have to do is below our initial spawn particle method, we're just going to create 2 more instances of that. Basically, loc1.getWorld again, just .spawn particle. And so the first one that I'm going to do is particle.crimsonspore. Particle.crimsonspore. This is going to be that pink floaty particle effect that goes along with it. And then same thing, we're going to give it X, Y, and Z. And then I want to just spawn 1 particle effect. And now with these 3 variables, I want to spawn it not directly on the line, but near the line. So what I'm going to do is I'm going to set the offset to be 0.5, 0.5, and 0.5. That way, it spawns within a block area of that position so that it doesn't spawn directly on the particle position every time. That just makes it look a little bit neater and a little bit more whole. Like, I just think it looks better that way. But we're just going to go ahead and do the exact same thing with the purple falling obsidian tier particle effect. Just do loc1.getWorld.spawnParticle. Particle.falling obsidian tier. Then we're just going to set the position X, Y, and Z. Then the number of particles we spawn 1. And then again, that offset, we just want it to be 0.5, 0.5, and 0.5. Perfect. And now, nice and simple, you can customize this however you want with whatever particle you want. And just kind of combining multiple particles into 1 particle effect, in my opinion, just makes it look a lot nicer, makes it look a lot more complete and a lot fancier. So now that we have this, let's go ahead and just hop into Minecraft and check out what it looks like. So we're here back on the server. Let's go ahead and just get right in the center here. Type in our command, CPE example. Then that'll be our first location. Then we'll set our second location here. And now here you can see our finished particle that we created. You can see how it has the purple and the pink particle effects along with it. That just gives it a neater and nicer look. Now the next variation that we're going to be making is a particle that is moving twice as fast, or however many times as fast as this particle. So with the current setup, this is basically as fast as our particle can go, but with this change that I'll be making in the next variation, you'll be able to make it go as fast as you want it to. So now looking at our code, basically our speed variable here is already set to 1, which is the fastest our particle effect can possibly go right now. So basically this is just like our maxed out speed at the moment, but there is actually a way around that. And the way around it is actually spawning in multiple particles in our run method here. And the way we do that is we're just going to go ahead and up here with our speed, I'm just going to create a new integer. I'm just going to call it particles per call. I'll just set that to be equal to 1 because that'll end up being what our particle effect currently is right now. And then all we have to do for that is within our run method here at the start, I'm just going to create a for loop for int I equals 0. And then while I is less than particle per call, and then I plus plus, then just going to go ahead and have those curly brackets there, and then I'm just going to take in everything we've already wrote within our run method and just put it right inside that for loop. And now nice and simple, basically whatever we have our particles per call set to, that'll be the number of particles that will spawn at once. So right now, since we have it set to 1, that's basically just the default, the same speed that we had before. If we set it to 2, it'll go twice as fast. If you set it to 3, it'll go 3 times as fast, so on and so forth. You can kind of play with that and the speed variable together to create different speeds and combinations. So nice and simple, but basically this will give you a lot more control over your particle effects. So I'm just going to go ahead and set that to 2, and now let's go ahead and just hop into Minecraft and see what that looks like. Now that we're back in game, I can go ahead and just run our command again. It'll be /cpe example. And I can go to my second point, go ahead and type in that same thing again. And then there you can see that our particle effect is moving significantly faster and it is spawning 2 particles at once instead of just 1. And now that we have this one all finished up, I can go ahead and show you the next variation of our particle effect, which is just going to have 2 instances of our particle moving along the line instead of just 1. So to have 2 instances of our particle effect moving along the same line, that is very simple. I'm just going to set that particles per call back to 1. And now in here, I want to change this index to index 0, and then I'm going to create a second index, and I'm just going to call it idx1. And then I'm actually going to set this one to be equal to particle count divided by 2. That way the first index will start at the beginning of our line, and the second index will start halfway along our line. And then nice and simple, just have to basically create everything we wrote and duplicate it with an index 0 version and an index 1 version. So I'm just going to do index 0 here, and then just going to copy this, paste it immediately after, just replace that with index 1, same thing with this, index 0, copy it all, paste it, and then make an index 1 version of all of them. And then just real quick, I want to do x0, y0, z0, and then x1, y1, z1. Then now we want to do x0, y0, z0, x0, y0, z0, 0, 0, 0. Then we're just going to go ahead and copy all of that. And then go down a couple lines, paste it, and then just replace all of these zeros with ones. 1, 1, 1, 1, 1, 1, 1. No shortage of ones here. Make sure we got them all replaced. We did, very good. And basically just creating multiple instances of our particle effect moving along the same line is as simple as that. You can create an infinite number of these indexes. You just have to make sure you set particle count to be divided by whatever number of particles you want it to be. And you just want to make sure you have like particle count times 1/3 for index 1, and then particle count times 2/3 for the third one. So on and so forth. Hopefully that makes sense, but this is pretty much the gist. Now that we have this, let's go ahead and just hop into Minecraft and check out what that looks like. So again, here we are back in Minecraft, so I can go ahead and just come over here, type in my command, get the first location for my particle effect, go ahead and get the second one, and then here you can see we have our final particle effect where we have 2 instances of the particles moving along the line. And now next up I'm going to show you the last variation, which is going to be the particle effect moving between the 2 points instead of just moving in one direction. So back in our code, I already edited the method so it looks like what we had before we did the double particle effect. Basically all we have to do here is we just have to create a new boolean here, boolean, and I'll just call it isForward, and I'll set that to true. And then here, right after our for method, I'm just going to do if isForward, and then I'll have an else statement in there too. Then I'm just going to take this index I created and just move that within my isForward method. And now I just want to change this a little bit. Basically, I just want to set isForward to be false. And then I want to set the IDX to be equal to particle count minus 1. That way it just keeps it at the end of that line. And then now in the else statement here, all we want to do is just basically the opposite of what I have in isForward. Just if minus minus IDX is less than 0. And if that's true, we're just going to set isForward to be true. And then I'm just going to set index to be 0. And now nice and simple, that is literally all we have to do for the reverse particle effect as well. Let's go ahead and hop into Minecraft and check out what that looks like. Now that we're back in Minecraft, I can go ahead and go to our starting position and type in our command /cpe example. And then I can go to the final position of the particle, type in the same thing. And then there you can see we have our final particle effect where it will be bouncing in between the 2 points forever. So that is all of the particle effects that I will be showing you in this version. In the next one, again, I'm going to be showing you how to create this multi-line particle effect, and then the video after that, I'll show you how to create this curved line version of the particle effect. But until then, I hope you enjoyed this video. Hopefully this tutorial was helpful. If you have anything in particular you would like to see in the future, please leave it in the comments down below. Or if there's anything that you would like me to clarify, anything I could do to improve this tutorial series, please let me know about that too. But thank you so much for watching, and I'll see you in the next tutorial. Goodbye.